All right, so on page 10, we're going to call this 3.4. We're going to say this is higher order factoring. Higher order factoring. We've already talked about the very first thing we always do is what? When we're factoring? GCF, right? That's been drilled into you. And so 1 and 2 are examples of a GCF. We don't need to talk about those. If we look at perfect squares, okay, so perfect squares is the next thing. And we know if it's perfect square is if it's a number times itself, right? Mm-hmm. So if we look at perfect squares, we know that that would be something like x and x squared, right? Those go together. Or you can do like 4 squared, that makes 16. Okay, there's multiple examples we could do. The rule when you have a squared minus b squared is that you find out what the square roots are. A and A, B and B, one's plus, one's minus. Right? One's plus, one's minus. So over here to the side where it has the formula, you can write it there if you want to. A plus B, A minus B. And A and B stand for perfect squares. So if we do a quick review here, number 3, does it have a greatest common factor between 9 and 49? There is no greatest common factor. Notice that all of them are perfect squares, right? So what's the square root of 9? 3. So put your parentheses up. A 3 and a 3. What's the square root of x squared? What about 49? What's the square root of 49? 7 and a 7. And then y squared? Y and a y. One's plus, one's minus. Remember that, right? Let's look at number 6. What do we always look for first? Because if you notice, 10 is not a perfect square, right? So this wouldn't work. So the greatest common factor is 10 what? W. A 10w. So if I pull a 10w out, I get w to the 4th minus 1. What do we have to look for, though? Is this perfect squares now? Yeah. Isn't w to the 4th a perfect square, right? W squared and w squared, okay? And then 1 is a perfect square. So this becomes w squared minus 1 and w squared plus 1. Do we need to, Mitchell? Yes. Yeah, we do need to pull that 10w down. Is this finished? Oh, look, w squared minus 1 can be factored again. Now, pause. Can w squared plus 1 be factored again? No, because it's addition, right? So I have my 10w out front. I'm going to write it up here. My w squared minus 1 becomes w minus 1, w plus 1. And then you have your w squared plus 1. That one's a long one. But you just have to keep looking to see if it's something more that can be factored, okay? We've been doing this the whole time. We're just reviewing this. Sometimes those I would call a loaded question. So if we look at sum of cubes and difference of cubes, okay? Sum of cubes and difference of cubes. What is a perfect cube? Anybody?
A number times itself 3 times.
Number times itself 3 times. So over here to the left, if you have room, we're going to make a little chart. X and x cubed. All right, so 1 is a perfect cube, right? 1 times 1 times 1 is 1, just like it's a perfect square. So our first one is going to be 1. What about 2? What is 2 times 2 times 2? 8. What about 3? In your calculator, this button right here, this is called a caret. That will do an exponent. So if you do 3 and then that button, 3 to the third power gives you 27. What about 4?
64.
4 to the third power is 64. 5 to the third power, 125. What about 6 to the third power? 216. That's as far as we're going to go today because we shouldn't see a ton more than that. All right? So we're looking for perfect cubes. Here's the rule for perfect cubes. Here's the formula. When you're doing the sum of cubes, that means you're starting with addition. Okay, so if it's an addition problem, that means you're going to use this formula. It says A plus B times A squared minus AB plus B squared. So this is new to you, and we're going to do a few, so don't panic yet. All right, so that's the formula that goes with the sum of cubes. This formula will never change. All right? So if you're looking at example 7, is x cubed a perfect cube?
Yeah.
Yes, right? X cubed. If you need to write this up here, this is the perfect cube column. So is x cubed a perfect cube?
Yeah.
Yes. Okay, so what is the cube root of x cubed? X. What about 27? Is 27 a perfect cube?
Yes.
What is the cube root of 27? 3. And the formula says plus. This has created your A plus B here. That's what you've done. You've created your A and your B. Okay, so now, over here to the side, let's write our formula right underneath this. Write the rest of your formula underneath it, please. All right, now it says take your A value and square it. So what was our A value? X. And so what is X when you square it? X squared. Then it says take your A value and multiply times your B value. So what is A times B? So that would be my 3 and my X, right? That's my A and my B. What's X times 3? 3X. Now, we had a positive 3X, right? But what sign does the formula say?
Negative.
We always follow the sign of the formula. So it should be a minus 3X.
So what if it? Oh no, minus is for addition.
We're going to do subtraction in a minute. Okay, then plus B squared. So what was your B value? B value is 3, right? And so 3 squared is 9.
That's it.
That's going to be it.
It's not that complicated.
Okay.
It's very long-winded.
Let's do another one. Let's do 8. First of all, is there a greatest common factor in number 8?
Yeah.
I want you to think about that before you just say yeah.
Oh, no.
They don't have anything in common, right? Are all three of those things, m cubed, 216, and n cubed, are they all perfect cubes?
Yes.
Yes. Okay, so, and it's addition. All right, so let's go ahead and write our formula first. While we get used to it, please write your formula. All right, so we're going to ask ourselves, what is the cube root of m cubed? M. So that's going to be our A value. And some of you, maybe it would be helpful to do this, where you're writing the cube, that thing, so you remember that little cube root. If not, it's not a big deal. What is the cube root of 216? 6. Is it just going to be 6 by itself? 6n, right? Okay. Don't talk when you're yawning, because it's hard to see. 216 has an n with it, right? So just like over here, if it has a variable with it, then the variable also comes down as part of the square or perfect cube.
But if it wasn't cubed, then would it still be?
No, but you won't run into that. Okay? All right, so we have our a and our b. So now it says take your a value and square it. So what's our a value? M. And so we're going to square that. And what is m squared? M squared. Okay? Then it says take your a value times your b value. So what is m times 6n, Aspen? 6mn. Now, are we going to use a subtraction sign or an addition sign, Ryan? Why? Because that's what the formula says. Good. And then Ashley, our last term is our b value squared. So what's our b value? 6 what? 6n. So how do you do 6n squared?
36n.
Thank you, Ashley. Your voice has changed. 6n times 6n, right? That's squared. So that would be 36. What? Ashley? In squared. Questions?
Okay, so you solve it when you, like when you're setting it up, you go ahead and square it and then also put the square out there again? Like, you get what I'm saying? Like, okay, your a squared plus ab plus, minus ab plus b squared. When you're filling that in, you go ahead and square the 6.
Yeah. You don't have to write 6n and then square it. You can just go ahead and do it.
And then you put it, when you do it, why do you write the square again?
Because it's 6n squared, and 6n squared is 36n squared. Okay, let's do another one, and then we'll see if you get it. Okay. Okay, so let's look at number 9. Is 500 on our list? Well, we didn't take our list out far enough, right? But what about 4? Is 4 on our list? 4 is on your list? As a perfect cube? No. It's not. Okay, so that's a good hint that maybe I need a what? Greatest common factor. Okay, so does 500 divide by 4? Let's check.
Yes.
What is it? 125. So if I divide it out by 4, I have 125 a cubed plus 4. This, I repeat, this is not your a and b, because you have not taken the cube root of each of these things, have you? That should be a 1, shouldn't it? This is not your a and b. This is just, you've done the greatest common factor. Now you have perfect cubes. Now you can use your formula. Okay? So, our a value, remember, our a value is the cube root of this first thing. We're going to hold off onto that 4 until the very end. So we're going to leave it alone. So what's the cube root of 125? 5. And the cube root of a cubed is just a. What's the cube root of 1? Okay, so now you have created your a and b. Okay, so you have your a plus b, and then you have a squared minus ab plus b squared. So what's my a value squared, Dalton? 25 what? Just 25a? 5a times 5a.
25.
A squared, right? If you have 5a times 5a, that's 25a squared. Okay? Next thing, a times b. What's a times b here, Daniel? 5a. And is it going to be addition or subtraction?
Subtraction.
Okay. Mitchell, what's the b squared term going to be?
The 1.
Just the 1. And 1 squared is just 1. Olivia, what do I need to make sure I put on this? The 4. Bring that down. Let's go ahead and do the difference of cubes. Because it's the same thing, the signs just change in the formula. Everything else is exactly the same. The signs just changed. All right? So let's look at...
I know what it is.
Oh, because you can see it up here?
Yeah.
Boom. Good job. Wait to be observant. All right, so let's go ahead and write our formula down for difference of cubes. And again, you know that to use a subtraction because it gives you a subtraction sign in the beginning. So this is going to be a minus b. Then a squared plus ab plus b squared. So everything looks the same except the signs. Yes.
Oh, never mind. Actually,
Squared, sign no change.
Correct. The b squared sign does not change. It's always going to be plus. Yep. All right, so let's look at number 1. Or by 1, I mean 11. So these are perfect squares. Nope, they're perfect cubes. So let's go ahead and write our formula out. A minus b, a squared plus ab plus b squared. Okay, so what's the cube root of x cubed, Taylor? The cube root of x cubed. What'd you say?
X.
Just x. That's going to be my a value. Alyssa, what is the cube root of 1? Just 1. So that's going to be my b value. Yep, because we're, yeah, good. It's going to be minus 1 because we're following the signs of our formula. Then we're going to take our a value and square it. So Donald, what goes in for a squared?
X.
Just x?
X cubed.
It says to square it, right?
Yeah.
So if it says to square it, we're going to make sure we square that. A times b. Vinny, what is a times b going to be?
Okay, hold on, wait a second. Okay, a times b is just gonna be 1x.
Okay, do we have to put the 1 there?
X.
No,
We can just put x, okay? And it's going to be plus, right? It looks like it's negative 1 times x, but it's really just, we keep the sign, right? Plus 1x. And then, Brooklyn, what's going to be my b value? Plus 1. Everyone okay with that? Same thing, just signs change. All right, let's look at number 13. On 13, what does it look like here? These perfect cubes? No. So that means we probably need to pull out a... All right, so if I pull out a greatest common factor, which would be what here? Okay, not just 2. We're going to divide by a 4.
We're at 14. Right?
Number 13. We're on 13.
Oh, okay, so that's 2. Okay.
Yeah, 13.
Oh, then yeah, we're gonna take 4 out.
Okay. 1 minus 8h cubed. Okay, so this is not my a and b because I haven't taken the cube root yet. What is the cube root of 1? 1. That's my a value. Do not switch it around. We're so used to seeing the a value be the variable, but sometimes the variable is going to be the last thing. It's going to be the b value. What is the cube root of 8? 2. What else needs to go with the 2? An h. It's going to be negatives because we're following the sign. It starts as a subtraction problem in the beginning, so it'll continue to be a subtraction problem.
Wait.
Okay, so then it says take your a value and square it. Remember, this is my a, this is my b. So my a value squared is what? Ben, what's my a value squared? 1. And then my formula says plus. A times b is what, Dalton? A times b. So my a value times b value, 1 times 2h is what? 2h. Okay. And then Cedric, what is going to be my b squared? Perfect. 4h squared, because that means 2h times 2h. Is this problem finished?
Yeah.
No.
Go, you go to 4.
Put the 4 in front.
Pull the 4 down. Good. You guys are so great to remember that it's during notes, and then it's like in homework you totally out the window.
So how come you don't put the squared on the 1? Like, I know.
Because you can 1 squared. Can you simplify that?
No, I know it's going to be 1.
Right. So if you can simplify it, then simplify it. It's the same way we don't leave it as 6 squared. We multiply that out to be 36. Okay? Last example, let's do 14. I want you to try 14 on your own. See what you can do in 14. Try it. Be careful as you're going. If you're watching the video, go ahead and pause and try 14. Okay, Ryan, what's the first thing you did on 14? Okay, which is what? Okay. So it leaves you with x cubed minus 27y cubed. Okay. Olivia, what did you do next? Cube rooted it? Yep. Okay, so what's the a value going to be?
1.
X, right? Okay. What's my b value going to be, Leanna? What's the b value going to be here? So what's the cube root of 27y cubed? 3 what?
3y.
Good. 3y goes with that. Okay, raise your hand if you have the x minus 3y part. Okay. All right, Braxton, what is my a squared term going to be? X squared. Then it's followed by a plus sign. What is my a times v, Vinny? A times b.
Give me 1 second. Okay.
My a times b value.
3y?
Just 3y?
3y squared, right?
So it says take your a value times your b value. So what is x times 3y?
3xy.
Okay. And then Mitchell, what did you get for your b squared?
B squared. Was it just your 3?
Okay, so it says to take this b term, which is here, and you're going to square that, right? So 3y times 3y is what?
9y
9y.
squared.
Yes. 9y squared. Guys, it's going to be really helpful if you put the formula down first, and we haven't done that in the last 2 problems. Put your 2 out front. Take it all the way out. Finish it. Okay, for homework this weekend, listen carefully. Go to page 13. You need to do 1 through 12. Are you on page 13?
Right here. You come up here?
Yeah.
Okay.
Yep. Page 13, it says homework 16 at the top. You need to do 1 through 12. And then you need to do, listen, 21 through 24. Do not X out of the other stuff. We're going to come back to it later. But for this weekend, you need to do 1 through 12 all. And then 21, 22, 23, and 24. Yep, on page 14. 21, 22, 23, 24. Those are 3 terms. How do you handle, 4 terms. What do you do with 4 terms to factor? Grouping, right? So that's stuff we've already done. All right? Have a great weekend.